Well, hello everyone, and welcome to the XMTP Developer Community Call. As always, thank you very much for joining us today. I'm Jeha. I work in Protocol Ops, and I'll just be our host for today. The webinar is being recorded for those who can't attend live, and we'll be sharing the recording for all to view. In the community forums after this call, I'll just put a link to the post where that will appear in the chat here. So folks can follow up there if you want to. And also at the start of each meeting, we drop a new NFT. It's a great tradition started by Naomi, our VP of Engineering at Ephemera, and we continue it to this day. So I'll share a link to that as well. You can mint for free on Zora. Zora was a little bit wonky earlier today, but I'm hoping that'll let us mint in just a tiny bit of time. And also, all of us here have seen this. All folks who join the call regularly notice that we do share the XMTP code of conduct at the start of each meeting, but I think that is also a great tradition just to reinforce that, for all of our public gatherings and in this XMTP call, we invoke this code to create a space where everyone feels welcome to share ideas and ask questions in community and in the interest of everyone learning together. So let's see here. I think everyone's familiar with the webinar format here, and we just use this webinar format for the safety and security of our community, but I will be quite diligent in keeping an eye on attendees here and questions in the chat and raised hands. And if folks on the Ephemera team can help me to do that, that would be great as well. In our attendees, for example, we just had Evan join us, so I've promoted him to panelist as well. And so let's go ahead and just jump into our main event today, one that I've personally been looking forward to. And I'd like to introduce Nick Molnar and Martin Kiesel to talk us through XIP-49, Decentralized Backend for MLS Messages. And I'll go ahead and put a link to the XIP in the chat for folks if they'd like to follow along. I'll hand it over to Nick and Martin.
Thanks. So I thought we'd just do a quick overview of the key components of the XIP. XIP-49 is, I believe, the longest XIP we've ever produced, and it's a lot to dig through. But there's a few areas that are particularly relevant for builders in the community to be aware of well before this gets shipped into production. So you can start thinking about how this might change your apps. Before we dig into the specifics of the proposal, it's helpful to think through what are the goals we had when designing a decentralized backend for XMTP. We knew we wanted there to be censorship resistance, so we can have many nodes that are all coordinating the replication of messages. But it also needs to be high throughput and low latency. This is a messaging network that we want to take on like Telegram and WhatsApp. And when you use an app like that, you expect a message to get delivered really quickly. And if it took blockchain times to deliver most messages in WhatsApp, you would just go to another app. We need things to get delivered in hundreds of milliseconds, not seconds, end to end, including, onto people's phones in different places in the world. And so those are really tight requirements for the latency of the system. And then the last item here is it needs to be cheap. These aren't multi-million-dollar DeFi transactions where maybe it's okay to pay a few dollars to get a message onto the network, like you might mainnet Ethereum. We need a network that is cheap enough that an app can subsidize it on behalf of many users and not break the bank. And so that forced us to be really disciplined in the design of the system to facilitate really cheap storage, much cheaper than a typical blockchain network. And I think we have a design that lets us check these boxes. Jeha, if you wouldn't mind popping over to the next slide. So the way we accomplish this is a two-pronged architecture. Most messages in a post XIP-49 world stay off-chain in a network of nodes. The reason we keep them off-chain is for both speed and cost, but this network of nodes has some strict rules around how it signs messages that it receives and how it replicates those messages to all the other nodes in the network. But then it can do this without a lot of fancy data structures, and that makes it much cheaper to store millions and millions of messages on these off-chain nodes. And that network works pretty well for storing messages that don't have ordering requirements. So maybe you get message 2, and then you get message 1, and message 3 comes a little later. That's perfectly fine for normal messages that happen in a conversation. But there's a few types of messages on the XMTP network that have stricter requirements. When you are updating your identity, we need total ordering to determine if an update is valid or not. And when you're changing the state of a group chat, say adding a member or removing a member, those need to be totally ordered. And so what we have done is split out the small subset of messages that need total ordering and put them on a set of technology that's quite good at total ordering, which is a blockchain. And so there is an L3 app chain that settles to base that handles this subset of messages that needs total ordering, and then the very cheap and fast network for everything else. And by doing that, we get the total ordering guarantees we need, but we also can max or minimize the average cost of sending a message. Messages on the blockchain will be more expensive because blockchains, but there should be relatively few of them. And so your average cost will be closer to the off-chain network. Messages in this architecture can be published to one node, or you can publish to multiple nodes to really protect yourself against any potential censorship in the network. That's not the only layer of censorship resistance, but it's one more layer that you can choose an application developer to add on top, which is just publishing your message more than once. So I've been talking a lot about cheapness and costs. Maybe this is a good segue to the payer service. This is a new part of an apps architecture in XMTP, specifically for apps that are serving many users. Not every app will need a payer service. Maybe you have a bot and there's only one application and one identity on our network. In that case, you might not need a payer service. But if you're an inbox app that has thousands or millions of users, you don't necessarily want them to have to accept a signature dialogue every time they send a message to approve the fund being used to pay the very minimal fees. That would just not work if you had a MetaMask pop-up every time you wanted to reply to a message or heart something. And so the payer service sits in between the user and the network and can subsidize the costs. The payer service would live in the backend so that it can protect the app's private keys. And you can think of it very similar to a paymaster in the Ethereum universe, where it is making decisions on which messages to subsidize and which messages it might not want to subsidize. And so if you're running an inbox app, you would have a payer service that has a little bit of custom authentication for your app so that you know this is one of my users and not a stranger, and then can maintain a balance in its wallet that gives it enough funds to subsidize the messaging cost per user. Because these messaging costs are fairly low, we hope that you can be pretty permissive with this. We are doing everything in our power to get messaging costs as cheap as possible to make this easy on payers. But ultimately, you still have to decide, do I want to pay for this message or not, even if it's a tiny fraction of a penny? And so we're going to be providing open source repos for the payer service and how you can modify it to meet your needs as an application developer. But this is a thing that doesn't exist in XMTP today, and so I wanted to touch on it here. Now you might be wondering next, okay, what does the payer service do with the message? Where does it go? So if this is a typical message, that doesn't need total ordering, it goes to the broadcast network. Broadcast network is explicitly not a blockchain. It is designed for replicating messages without consensus, and that gets one message to every node in the network as quickly as possible. So if I'm talking to one node when I publish a message and you're reading from another node to get your messages, we are minimizing the latency to get the message point to point. And so the broadcast network takes a message in and then sends it to every other node in the network. The reason this can work is because we've explicitly designed the broadcast network to be relatively small, targeting maybe 10 to 20 nodes that are high quality and high performance and located all around the world so they can be close to the end users. Each of these broadcast nodes is then going to sign a message and, importantly, commit to the local ordering. And so while the network doesn't have global ordering guarantees like a blockchain does, it does guarantee the order of the messages that were published to that node. And that can be used to come up with a sensible order inside each client for how you should show messages to the user and which came first. And it should be indistinguishable for a user from total ordering in most cases, because we are going to be routing most writes for a given conversation to one node or another. The node is also responsible for making sure that the payer who signed the message has the appropriate balance to actually pay for the storage of the message. And so each of these broadcast nodes is going to do a check and make sure that you can afford the message you're sending, and then it replicates it out to the rest of the network. This is designed for very low cost storage in the broadcast network. We are able to store messages in a relational database, and we can have nice indexes on it so that it's immediately available to be queried by anyone else as soon as it gets processed, which is very different from blockchain, where you have to wait for some period of time for the network to reach consensus. As soon as you have processed a message in the broadcast network, it is ready to be read by someone else, and that really helps with the speed. Maybe we can hop to the next slide, the app chain. So this is for the small subset of messages that need total ordering. We do this as an Arbitrum Orbit L3 blockchain that settles onto Base. It has these strong ordering guarantees, and everything that happens on the app chain related to the XMTP network gets indexed by all the nodes as quickly as they can. This will be higher latency than the broadcast network, but it should be for pretty rare message types like adding and removing members from a group or initially registering your app on the network. And so in those cases, we think it should be fine to wait hundreds of milliseconds or maybe up to a second in some cases before it's propagated everywhere on the network. These messages on the app chain are paid for just through gas. We don't charge any additional fees beyond the gas required by an Arbitrum Orbit chain. And they spit out events that get indexed by all the nodes. So it's actually very simple smart contracts that are running on the app chain. And we're primarily using the chain just for the ordering guarantees that you get and the censorship resistance you get out of an Arbitrum Orbit chain. Even if you don't like our sequencer, you can always use forced inclusion to get your message onto the chain. And so the app chain provides the last line of censorship resistance, where even if every other part of the network doesn't want your message to be shown, you can use forced inclusion on Base to get your message displayed. And so that's a really powerful tool that shouldn't be used very often, but allows us to credibly say that this is a truly censorship resistant network, even with really extreme scenarios of all the nodes and our sequencer working to prevent your message coming onto the network. So I think those are the main moving pieces of, the app chain. At this point, happy to open up the floor for questions. I'm sure a lot of you are wondering how this is going to affect your apps and what this is going to look like. I can talk a little bit about timelines. We're expecting that the new decentralized network is going to launch in H2 2025. And there'll be plenty of advance warning before anyone has to upgrade. But what else can I answer for Martin about the new decentralized XMTP backend? All right, if there's no questions now, we can always leave some time at the end of the call to chat some more.
Actually, we have a great question from Morgan in chat.
Oh, there we go.
Thank you.
Yeah, that's a great question. One of the nice things about this network is we don't have to apply the same blunt force rate limits that we apply today, having one network that is meant to serve bulk senders and regular users. So if a message is paid for, it can be accepted by the network so long as the network has capacity. And we're doing everything in our power to make sure the network has a lot of extra capacity. So you should very rarely run into rate limits, even if you're sending a lot of messages in a short period of time. Yeah, one of the motivations of this was to get rid of our very, simple throttling mechanism for bulk senders. If you have the funds to pay for a message, you should be able to get it onto the network as quickly as is humanly possible. And so for most users who are getting throttled today, the problem should go away. It would be only pretty extreme cases where the network would be congested enough to force you to slow down. Group messages and DMs would have roughly the same costs. Certainly application messages are exactly the same. Application messages are the normal messages you send, hello, GM. The only difference for group messages is that in a big group, some of the operations you do lead to bigger messages because you have a lot of members. And so messages are metered by the byte. And in a really large group, some of the messages might take up more bytes, but otherwise the fees are exactly the same.
I have a question, Nick. I'm wondering what really stood out to me was in when we were talking toward the end of App Chain was about like the last line of defense around ensuring censorship resistance. And I'm wondering if you might be able to talk a little bit more about how that works.
Yeah, so the way that um, any of these roll-ups that are optimistic can achieve censorship resistance, even if you have, for example, a centralized sequencer, like the first version of our app chain will, is that you can always go onto base and submit a transaction and have it forced into the app chain through forced inclusion. And by doing that, we have no control over whether it gets accepted or not. The rules of the rollup are that any message sent that way has to become part of the state of the network. And so no matter what, you can use, if you can use base, you can send a message to XMTP through forced inclusion.
Oh, thank you. Any other questions, thoughts, anxieties, praise? That's great. All right. Well, we have of course, questions are welcome at any time in the forum, in Slack, on X, Warpcast. So if anything comes to mind, please do reach out. And thank you again, Nick. Thank you, Martin, for walking us through it today. Cool. All right. Next up, we have engineering updates. Naomi, are you available to share the latest from the engineering team?
Yeah, of course. Thanks, Jeha.
Yeah, great.
So we are working hard over here on some final little pieces of V3. So right now we're working on disappearing messages. This will have a worker that you guys can set a time for when you want your messages to get deleted, and they'll kind of get deleted from everybody's local database. And if you're familiar with how our network works, they won't get refetched. So it kind of is a delete for everyone as best as possible. We're working on backups. This one's going to be a little bit further out, but we're working through what this would mean to be able to back up your app and then re-upload it, to a cloud or something. Multi-remote attachments. This is a codec kind of like our remote attachments, but allows you to attach multiple photos to one message. Additional chain support. This is hopefully we're going to have an XIP out this week to kind of talk more about what we mean by additional chain support. And then as you just heard from Nick's talk, we're full steam ahead on decentralization. So yeah.
Great. Thank you, Naomi. And any questions, any feedback on that? And I'm just grabbing the XIP for multi-remote attachments content type if anyone's interested. All right. Thanks so much. And next up, we have Saul with an update on XMTP V2 deprecation plan. Very important
Thank you,
information.
Jeha. Thanks.
Yeah.
So the next key milestone in our transition to the decentralized network that Nick outlined is the May 1st deprecation of the V2 network and incompatible V3 SDKs. So to prepare for this, we're releasing new stable V3 SDKs for all platforms, React Native, iOS, Android, browser, and Node on March 3rd. These will include production-ready groups and DMs that are propagated exclusively on the V3 network, improvements in performance and stability, and a new disappearing messages feature marking XMTP's completeness as a modern secure messaging protocol. So developers will have 2 months to upgrade to these SDKs before all older versions are disabled on May 1st. If you're already on a V3 SDK, this should be a straightforward update. If you're still on a V2 SDK, we highly recommend you get started on your V3 upgrade ASAP. Biweekly brownouts of the V2 network will begin April 1st, where we'll be turning the network read-only for a few hours to alert any devs who are still using it. Thanks. Any questions? And thank you for sharing the link with further details on this, Jeha.
Oh, sure. Nice. And we'll be repeating the guidance with each call and through any other channels. So there will be reminders. Let's see here. Yes, great question, Morgan. V3 Web SDK is all good. And
V3 Web SDK is definitely all good to be building on. All SDKs will have an update on March 3rd, so including the browser SDK. There will be an update on March 3rd that you'll need to be looking out for. But absolutely, if you're building on V3 now, keep building on V3 now. That should be a very straightforward upgrade.
All right. Hey, Morgan, I have a question for you. How do you keep up with your SDK upgrades? How do you know when you should do it?
Some of it's like calls like these. It's probably a better question for Marco, who kind of like is the brains of the operation over here. But mainly it's working directly with the teams whose kind of like technology that we're using. So whether it's talking with your team directly, or other teams like that we're familiar with, like Unicro, that helps run kind of like our smart contract system. It's at this point just a direct relationship. For kind of like we try to keep obviously that overhead as light as possible for the number of technologies that we're using. And that gives us the benefit of being able to work directly with our partners.
Great. Thank you for sharing that. Yeah, always looking for ways to make that communication easier for you. So thank you for sharing. And now I'll open the floor. Anyone have anything they'd like to share? Any questions? Any insights? All right. Well, thanks so much, everyone, for joining. And good to see you all. And we'll see you next time. Thanks so much.